Hello, everybody. This is just going to be a little video going over the notes and the PowerPoint slides that are on the website for the unit on scatterplots and least squared regression lines. I also posted another video that's on the page that explains how to actually input the data into StatCrunch and come up with the equation. This video will talk about how to use that equation to make predictions. Okay, so creating a scatter plot on StatCrunch is something you want to make sure that you're able to do by the end of this week. Find the equation for the linear regression line, which comes right from StatCrunch. Understanding the strengths of linear correlations, the different R values. Find and understand the meaning, the meaning of the coefficient of correlation, the actual R value, understanding what that tells you. And then being able to make a prediction for an output value or Y hat given a specific X value. So these are all things we're going to see and talk about in the PowerPoint and things we will practice going into next week. All right, so some vocabulary words. Scatterplot, we mentioned that real briefly on the very first class when we were talking about quantitative data. Scatterplots can be used to show quantitative data on a coordinate plane. So each piece of data actually has two values, an X and a Y. Now those X and Y values could be anything. We're going to look at an example of hours studied versus test score, hours worked versus salary made, whatever it might be. There are two data points for each piece of data, an X and a Y coordinate. The explanatory variable, X, a lot of people just remember explanatory and X because explanatory has an X in it. So explanatory is the X value, also referred to as the input. And then the response variable, or Y value, is the value obtained for a specific X value. You input the X value, and your output is the Y value, or the response. Okay, so the reason these names exist is because we're saying X is explaining the response that we get. X is explaining whatever that output is. So hours worked explains money made, the response variable. That would just be one example. Okay, so explanatory is the X, response is the Y. Not that big of a deal, but if you see those terms somewhere, I just want you to be familiar. Explanatory X, response Y. All right, so when we make a scatter plot, we are just going to make a bunch of points on a graph. Now those points are specific X and Y values, but let's say we have something that looks like this and we have some points, whatever these points represent. There's something called the correlation coefficient, which we just use the letter R to represent that number. R is going to be a number that's given to you in StatCrunch. If you've watched the StatCrunch video, you will have seen that that number just pops up when you calculate the equation. The things you do need to know without StatCrunch is that R goes from -1 to +1. The smallest R value is -1, the largest is +1, so it's something in between. Now, -1 and +1 also mean the same thing in one regard, because they mean they have the same strength. So when we talk about a correlation, one of the things that we refer to is the strength. So the closer the R value is to -1 or +1, the stronger the linear relationship. Now I'm writing on the PowerPoint slide. I'm hoping the words are popping up as I speak, because otherwise there'll just be a bunch of dramatic pauses in there of me talking and nothing being written on the screen. So if it is not showing up, which I won't find out until after the video, I will repeat what I just said and hopefully wrote. It says the closer the R value is to -1 or +1, the stronger the linear relationship. So +1 and -1 have the same strength. It's just one is referring to a positive correlation and one is referring to a negative correlation, which we'll talk about in a minute. All right. If R is close to 0, it just means there is no linear relationship between the variables. So +1, you have a positive relationship, -1, negative relationship. The closer you get to 0, it means there's less and less of a linear relationship, where 0 implies that there is no linear relationship whatsoever. Okay, I'm going to show you what that might look like visually. This is just talking about if R is positive. If R is positive, that means as one variable is getting larger, the other is getting larger as well. It could also mean as one's getting smaller, the other one gets smaller. That's saying the same thing. As X goes up, Y goes up. Or if you were going backwards, as X goes down, Y goes down. They're doing the same thing. It's a positive relationship. If R is negative, it means that as one variable gets larger, the other gets smaller. As X goes up, Y goes down. Or as X goes down, Y goes up. They're doing the opposite. It's a negative relationship. Okay, so positive, the variables are both doing the same thing, going up or down. Negative, one's going up, one's going down. If you remember back to some algebra-based class when you were talking about lines, if something had a positive slope just meant that the line was going up, something like that. If you had a negative slope, you had something going down like that. Same thing with correlation, positive versus negative. Okay. More about correlation. Here's the visual of what we were just saying. There's a positive correlation. Here's a negative correlation. As X is going up, Y is going down. And then over here you have no correlation. You can't really tell what's going on. Sometimes it goes up, sometimes it goes down. Whereas in the positive, you can see it's pretty consistent going up. Negative correlation, it's pretty consistent going down. But here, there's no reliable correlation. You can't really tell what's going on. It's not really going up or down. So when you have a positive correlation like this, you can see they're pretty close together. That would be a pretty strong correlation. In this case, R would be close to +1, maybe 0.9, 0.99, who knows, somewhere in there. But R would be close to 1 because as X increases, Y is also increasing. As X increases, Y is increasing as well. In the negative correlation, those are also pretty close to being on the same line. So this R value would be close to -1. They're both equally strong, meaning the points are really close to being on the same line as they are over here. It's just in this one, the negative one, the line's going down. So this R value would be close to -1. As X is increasing, Y is decreasing. They're doing the opposite. And then in the other one, since there's no correlation there, this one would have an R value that's close to 0. There's no linear relationship. I couldn't really draw one line that best represents this data. Right. Now, in the real world, the stronger your correlation, the more likely it is you'd be able to predict what was going to happen. Doesn't guarantee anything, but if you had a very strong correlation, all the points were on the same line, we would feel pretty confident about our prediction. To go back a slide, if we were looking at this positive correlation, and I said, when X is this value right here, whatever that number is, let's just make it up. Let's say that's X is 20. I would be able to make a prediction that the y value is probably going to be somewhere in this range right here, because if I was to continue this graph going up, I would probably see my graph somewhere over here, my point. So if I said make a prediction for when x is this value right here, everybody would probably make a prediction somewhere in this range up here. In the negative one, that's a strong correlation. If I said make a prediction for when x is this number out here, I'd probably make a prediction somewhere down here. But everybody would probably make a prediction close to this range here. Whereas this one, where there's no reliable correlation, if I said when x is this value, make a prediction, you have no idea. Maybe it's up here, maybe it's down here. We don't feel too confident about guessing or making a prediction as to what's going to happen. Whereas in the others, we feel more confident in our prediction because there's a stronger correlation. All right, so here, this is showing you r equals -1 and r equals +1. Those are considered perfect correlations, meaning every point is on the line. Every single point is on the line. Every single point is on the line. A perfect positive correlation would be somebody who worked for an hourly wage. Every hour, you go up the same amount. Let's say you go up $15 an hour. So you work 1 hour, you go up 15. Work another hour, go up 15. Work another hour, go up 15. That's a perfect positive correlation. Somebody who might have a positive correlation that's not perfect, if you work in sales, just because you work 1 extra hour doesn't mean you're going to make an extra $15. Maybe 1 hour you'll make an extra 50. Maybe another hour you'll only make an extra 10. It's still going up. The more you work, the more money you're going to make in general. But it's not going to be a perfect correlation where you're doing the same exact thing every time. So that hopefully just explains what the R value is telling you, give you a little more insight as to what that number means on the screen when it pops up on StatCrunch. You're never going to have to calculate it by hand, but it is important, or at least good to know, how to interpret that value. These are just some other examples of R values of 0, no correlation, -0.3. So it's going down, but it's very weak. The points are very spread out. So it's a weak correlation. It's close to 0, but it is kind of trending down. Here, you can see the points are kind of trending up. They're a little closer together than in the previous one. So it's positive, maybe around 0.5. Here, this one you could clearly see the points are going down and they're getting a little closer together. So negative, because they're going down. And 0.7, because they're getting closer together. Here, definitely going up, positive. Points are getting pretty close together, positive 0.9. And here, they're almost perfectly linear. They're really close together. They're definitely going down, negative 0.99. This is just showing you different strengths of correlations based on these R values and what the graphs might look like. All right, so hopefully that kind of clarifies the R value a little bit and gives you a little more insight into correlation. This video is just a video tutorial of how to do the same stuff on StatCrunch. I made a separate video that I talked over as I was doing it myself. It might be a little bit easier to follow than this one, but this one was in the PowerPoint, so I just figured I'd leave it. Line of best fit, we'll get into that. We're not going to watch this video here. If you'd like, you can watch that on your own. Okay, the equation of the least square regression line. Now, in the video I made about StatCrunch, StatCrunch gave us an equation. And we typed in our X values and our Y values into list 1 and list 2. Now, instead of X and Y, StatCrunch says var1 and var2. So you could delete var1 and var2 and type in X and Y. But chances are, if this is a test question, those variables are going to be defined. So in the example I used in the video, I believe one of them was hours, and then the other was test score. It was talking about how long you're going to study versus your test score. So just thinking in general, we would think that that was going to have a positive correlation. The more you study, the higher your test score. It kind of makes sense. Doesn't necessarily mean it's going to happen, but in general, if I looked at how long people studied and then looked at their test scores, there'd probably be a positive correlation. As one went up, the other went up as well. All right, slight changes to the equation you would remember from algebra. In algebra, you talked about y equals mx plus b as the equation of a line. This is the same equation, but in statistics, they don't necessarily use the same variables, same letters. Honestly, I don't know why they use m for slope in algebra. I personally don't when I teach it, because it's the only class that you would see the letter m. In every upper level math class, they would use A or B, depending on the scenario. Your calculator uses A or B, depending on the scenario. So honestly, I don't understand why they use M. I've looked into it. I've tried to find the word slope in numerous languages, and none of them represent an M in any fashion. So honestly, I don't know. Somebody just picked it and it kind of stuck. Kind of like the name for pretty much everything. Somebody had to originally just pick it and they just stuck. But anyway, we have a, b, x, we have a y, and then we have this symbol here. This is read y hat. The y with the little hat on top, and it's the little caret symbol. This symbol, anytime you see it above something, whatever it is, a y value, a variable, this little hat stands for the predicted y value, or whatever it is. If it's x value, where you see this symbol over the x, or you see this symbol over the word hours, or you see this symbol over the word test score, anytime you see this little caret symbol over something, it stands for the predicted value, whether it's predicted number of hours or predicted test score or predicted y value. Whatever that symbol is over, it stands for the predicted value. Okay, what we're doing here by coming up with an equation for what we call the least squares regression line, or the line of best fit, is we're looking at previous data. In a business, we might be looking at previous sales for the month. In stock markets, we might be looking at the cost of the stock or the amount of stock purchased over a specific period of time. But we're looking at data that we already know exists, things that have already happened. We don't have to predict what's already happened. We know what's already happened in the past. We're trying to use that data to make predictions for values that we don't know. Maybe we're trying to figure out how many of this new, whatever we're talking about, we're making a new TV. We're going to start selling this new TV around the holidays. We want to know how many we need to order before we sell them. We could look at previous sales of TVs, or how many sales we normally have around the holidays, and try to figure it out from that. But we're going to look at some previous data, whatever data we find relevant, and we're going to use that data to try to make a prediction. Because when people predict things, they tend to do the same thing, meaning they tend to predict too high or they tend to predict too low. In class on Saturday, hopefully the internet and everything's working where I am, and we're going to do an activity where you're going to be guessing the ages of people. And in general, people tend to guess too young or too high, too old. But what the least squares regression equation would do is it takes into account how far off you are in general. Maybe on average you're 2 years too young or 3 years too old. And it comes up with an equation that when you plug in your prediction or you plug in your guess, the equation is going to give you, theoretically, a more accurate prediction. maybe your guess is more accurate 40% of the time. When you plug it into the equation, it's accurate 60% of the time. So if you just had to pick one, you would pick the one that's going to be more accurate more often than not. That doesn't mean your guess is going to be less accurate every time. It just means that if you were to do this 100 times, probably more than half of them would be closer for the prediction than just your regular guess. Okay. As far as this class is concerned, that's not really the important part. The most important part in this course is being able to type the data into StatCrunch, get the equation, understand the R value, and then make a prediction based on your equation. So that's what we're going to look at. All right. Let's try to change the slide here. Okay. So here was an example. In this chart, you see an X and a Y. So if you've already watched the StatCrunch video, I would recommend pausing this video now and opening up StatCrunch and typing in your X's and your Y's, and then trying to come up with the least squares regression equation. Okay, so if you've already watched the how-to StatCrunch video that I posted under today's class, or this week's class, I should say. I don't know when you're watching this. But I would pause it and I would try to do it on your own. If you have not watched that video yet, I would also pause this video and I would go and watch the other one at this time. That way you could practice this problem on StatCrunch. Okay, so I'm going to just wait a second here. All right, so for those of you who tried this example on your own, if you typed all those numbers into variable 1, or X if you just named it X, and you typed all of the other values in for Y, or variable 2, if you did this on StatCrunch, this should be the first part of the printout, the digital printout that you get on StatCrunch. Your dependent variable, Y, your independent variable, X, or it would have said var1 and var2, or var2, var1, depending on how you typed it in. But the important part is being able to get this equation right here. On your second exam, there's going to be a question similar to this where you have a table and it's going to ask you to come up with the least squares regression equation and the R value. So StatCrunch gives you all this. So the R value is approximately 0.99. If it asked you to explain what that means, this would be a strong positive correlation because it's very close to positive 1. And you can see here, it goes up and then goes up, goes up. Doesn't go up there, but then goes up again, goes up again. So you can see as X is going up, Y is going up, it is positive. And if you were to look at the graph itself, you'd see these points are pretty close to being on the same line, something like that. Now to write the equation, this is the one thing you have to do, one thing slightly different than what StatCrunch does. StatCrunch gives you this equation. What this is saying is when you plug in X, whatever X might be, you're going to get Y. Now, to relate it to the test score problem I showed in the video, if somebody came up to me and said, I studied 8 hours, I might be able to make a prediction for what their test is, but there's no way I would know it. That would save me a lot of time grading, but I would have no idea. I can have an estimate, but I wouldn't be able to predict it. So if they told me their X value, their hours studied was 8, I could come up with an equation, plug in 8, and I'd get a number. That number is not the actual test score. It might be, but what it's giving me is the predicted test score. So when you see this equation, you can't write this equation. You have to write the exact equation. So that's 14 0.75, and I'm going to go out 3 decimal places. So 753, if I round off to 3 decimal places, plus 1.891 x, if I round off to 3 decimal places. That's the equation I have. If we want to talk about a predicted y value, though, we have to put a hat above the y value. And now this is the equation. Because when it was just y, that's implying when I plug in x, I'm going to get the y value. We're not going to get the y value. We're getting the predicted y value for a specific x value. Okay, so when StatCrunch gives you this equation, you copy the exact same equation. If you plugged in names here, if you said hours and test score, then you would write the word test score with the hat on top. Whatever StatCrunch gives you, you copy it, and then you would just put a little hat over whatever the y value is. Okay, and there's the graph. Let me erase what's on the screen here. So there's the correlation. You could see the scatterplot, I mean. You could see it's a very strong positive correlation by looking at it. And you can see that was close to 0.99. All right, here's another example, which again, if you know how to do this already, if you've watched the StatCrunch video, I would just pause it again and try to do this on your own before I go over the answer. Either way, it's fine as long as you know how to do it. But if you'd like to pause now and try it, and then come back to the video to see the answer, you can do that. All right, so this table shows the number of students enrolled in Math 253 at CCBC in 6 of the last 7 semesters. Not a heavily taken math course, but it is, something that happens at least once or twice a semester. The number for the third year has been misplaced. Let's say they lost it. We want to estimate the number of students enrolled in Math 253 in the third year. So if we're going to estimate it, just by looking at the table, we could probably get a general idea. Third year, this one, it goes down, then it goes up, it goes down a little bit, stays the same, goes up. But if we look at year 1 and 2 versus years 6 and 7, you could probably see that it's going to go up somewhat. So maybe your guess would be somewhere in the 30s just by looking at this. I wouldn't have any other logical reason besides just saying it's probably somewhere in between. But in order to do this, we would calculate the linear regression equation, or the equation for the line of best fit, same thing, on StatCrunch. My x values, I type in my year. My y values, I type in the number of students. And if you do this on StatCrunch, there's your scatter plot. You can see it's positive, but not very strong. Somewhat strong, but not too strong. We'll look here. Dependent variable, the y value, which is the number. The independent variable, your x, is the year. And here's your equation. So if the question said, what is the equation? I would write exactly what's on the screen, number, hat for my predicted value, and then I'll go out 3 decimals again, 24.839 plus 4.199, and then the word year. You can use the word of the variable instead of x and y. If you were to use x and y in your answer, if I wrote x and y, somewhere in your problem, you would have to say x equals, and then you would just say year. And then y is equal to number of students, something to that effect. If you use x and y, you have to do that. If you don't use x and y, if you actually use the words number and year, then you don't need to, because I could see where the year is, where the number is. But if you just use x and y, I don't know which one's which. So you would have to say x represents this, y represents that, somewhere in the problem. Okay, but that would be your equation. You can see the correlation is 0.87, so it's pretty strong, positive, going up. But this question was asking to estimate the number of students enrolled in the third year. So this was our StatCrunch output. Sorry, this is our output on StatCrunch. So here's the equation. Number hat equals this. And now we want to make a prediction in year 3. So to do that, I'm going to plug the number 3 in for the year. And I could just type this into my calculator. And if you do that, you're going to get about 37.4, which this is representing the predicted number of students. So that means in year 3, we can predict an estimate of about 37 students. So we went in the StatCrunch, we came up with this equation, and now it's asking us to make a prediction for year 3. So all we did is plug the number 3 in for year, and then you can just write this as your answer, which means we can predict an estimate of about 37 students, something along those lines. But that number, that's not the number, that's the number hat, because that's the predicted number of students. So we're predicting 37 students. Hey, here's another example on your own. I am going to post the answer to this one. This is something we will talk about, though, on Saturday. Keep in mind, Saturday, the Zoom meeting is going to start at 10 o'clock. If you watched both of these videos, you should be in pretty good shape as far as what you need to know. And then we'll probably only meet for about an hour on Saturday, 10 to 11-ish, just because I don't know how great the Wi-Fi signal is going to be. I'm going to be in the middle of nowhere in Pennsylvania, but it says there's decent Wi-Fi, so I guess we'll play it by ear. But I'll probably be teaching outside. So anyway, with that, I'm going to stop there. I'm going to post the answers to this one. So this is something you could try on your own. These are the heights in inches for giraffes at the ages of 18 months up to 29 months. And then there's predictions for 21 months, 28 months, and then 20 years. So we're going to talk about this one on Saturday. I mean, we're going to look at all of them, but we're going to talk about this one in particular on Saturday because it has a special name. So hopefully these videos helped you understand instead of just me posting the PowerPoints. Hopefully everybody's having a good week and you have a great weekend, and I will talk to you guys on Saturday around 10 o'clock. So thank you again and have a good day.